Do you feel the vibes?
Right. So before we do that, I actually want to, talk about some concepts here. So we have been talking about, this circle, right? And, if this is, 0 degrees or radian, by the time you get to, the opposite side of a semicircle, how many radian have you walked over? How many radian? In okay, so half the circle is 180 degrees, right? But in pi, how many pi was that? 1 pi, right? So over here, that was 1 pi. So now, if I split this down the middle again, okay, now this here, this point up here, if the semicircle was 1 pi, this is exactly the halfway point. So this is half a pi, which is pi over 2. Okay? So just like we know that each corner here is 90 degrees, right? So I go, from 0 to 90 degrees, 180 degrees, 270, 360. The same thing, each corner is half a pi. So if I go up here like this, that's half a pi. Another half pi is a full pi. Now, when I go here, it's a full pi plus another pi. So it's 1 plus a half pi. Well, in proper fraction, we write that as 3 over 2, right? So this is 3 over 2 pi, which means it's 1 pi plus a half pi. This is 1 pi and then a half pi. And then if I go another half pi, now I got 2 pi by the time I go over here. Okay. Right. That's equal to 360. Now what we're going to do is we're just going to focus on the pi, right? Just focus on this. And we're going to see how else we can split this. So right now we split this down the middle and we have pi over 2 at the center of it. Okay? Now, imagine you had, a chocolate bar, right? And so that's a full one. Now, if you split it in half right there, that's half of the chocolate bar, correct? Now, suppose you have the same chocolate bar, okay? But now imagine you want to split it into thirds, okay? If you split it into thirds, here's my question. Will 1/3 of the chocolate bar, will it be more than or less than half of it? 1/3 will be less, right? Because if I split it into thirds, this is 1/3. Okay, now, same chocolate bar. Now, I want to have 1/6 of it. So is 1/6 more or less than a half? Is 1/6 more or less than a third? Less. 1/6, right? If this is thirds, 1/6, right, is this much. Okay, that's how much it is, 1/6. So now, let's go back over here. This is a pi, okay? This is half a pi. If I talk about a third, is that more or less than a half? It's less than a half. So a third of a pi is about here. That's less than a half. So that's pi over 3, 1/3 of pi. Now, how about pi over 6? How about 1/6 pi? Is that more or less than a third? Less than a third. Pi over 6, that's this much. Okay? So now we're going to take each of these and we're going to see how we can transform them or translate them to the other quadrants. Okay, now this corner is half a pi. How much is a quarter of a pi then? Right? It's exactly half of that, right? So a quarter would be, if I just split that, right there. It's all the increments. So now these numbers are special numbers that you have to keep track of. All right. So pi over 6, pi over 4, pi over 3. These are like, so if we take a look at this now, let's just focus on the pi over 6. The pi over 6 is right here, and we said that is the smallest increment that we are going to deal with, okay? So, but because the ones we have are the pi over 6, pi over 3, pi over 2, pi over 4. So the pi over 6 is the smallest increment. So that's the smallest amount we ever move from the x-axis. Now, if I go on this side, that same amount, that will correspond to here. And if I go on this side, that same amount, that will correspond to here, and that will correspond to here over there. So now we're just going to focus on those pi over 6s. So why don't we go over to our notes? Here, okay, these are the equivalents of those pi over 6s that we talked about. So this is pi over 6, okay? That's if I took this half circle, and divided it into sixths. Now, I want to label the other 3. So here's how I do it. I basically have pi over 6. That's 1 pi over 6. Okay? And now what I'm going to do is I'm going to change that coefficient. So from 1 pi over 6, I'm going to go to 2 pi over 6. Then from that, I'm going to go to 3 pi over 6, 4 pi over 6, and so on and so forth. So now, this 1 pi over 6, there isn't much I can do there. But the 2 pi over 6, do the 2 and the 6 cancel with each other? And when they do, the 6 becomes a 3, right? The 6 disappears. Okay, so I'm going to keep doing this, 1, 2, 3, 4, 5, until 12. I'm going to throw away all of the ones where the 6s disappear. I'm going to keep only the ones where the 6s do not disappear. So 1 pi over 6 is one that I like. Now, 2 pi over 6, the 6s disappear, so I don't like that. Okay, I actually have it tapped up over there. 3 pi over 6, the 6s disappear. 4 pi over 6, 4 and 6 reduces to something over 3. I don't like that. 5 pi over 6, you can't reduce them. The 6 will stay. So this next one will be 5 pi over 6. 6 pi over 6, the 6 is reduced. The 6 goes away. 7 pi over 6 can't reduce. 8 pi over 6 reduces. 9 pi over 6 reduces. 10 pi over 6 reduces. 11 pi over 6 does not reduce. So that's the next one, and I've completed my 4. Now, this you should be able to do at any given time, okay? You are never going to memorize what number goes where, because this is only 4. We're going to have a lot more. Like, we're going to have like 15. So, more than that. We're going to have like 20. You're not going to memorize. You're going to understand. Yes?
Where you wrote pi over 6 like twice, is that because it's like the same line?
No, this is pi over 6.
Right, and then
This is 5 pi over 6. This is 7 pi over 6. Sorry, it doesn't. 7 pi over 6.
Wait, sorry, how do you get 5 pi over 6?
Okay, so let's do this again. So you're here. This is like a clock, right? You have 1 pi over 6. Now you have to keep changing the coefficient 2, 3, 4, 5 until you get one where the numbers don't reduce. 2 pi over 6 reduces. 3 pi over 6 reduces. 4 pi over 6 reduces. 5 pi over 6 never reduces. 6 pi over 6 doesn't work. 7, 8, 9, 10 reduce. 11 pi over 6 doesn't reduce. Now what's 12 pi over 6? What does it reduce to? 12 pi over 6, it becomes 2 pi, right? That completes the circle. Okay? Yeah.
Does it matter which one you put?
Yes, absolutely.
I don't understand like how like
They go in order because look, it's 1 pi over 6. Now go up in order. 2, 3, 4, 5 pi over 6. Everything goes counterclockwise, right? Counterclockwise is always positive. Okay, now let's do the pi over 4. Now remember we said if this was pi over 2, pi over 4 is exactly half of that. So now this is pi over 4.
How do you determine which one is like the first one?
Well, that's what we were doing before. Is like if you split something into sixes, it's the smallest amount. So from here, it's the smallest amount that you go, and then the pi over 3, right? It's like how it is in relation. Huh?
Does it matter if I go like?
Yes, it has to go counterclockwise. It has to go counterclockwise because that's the positive. So 1 pi over 4. Now 2 pi over 4 reduces, right? The 4 goes away. 3 pi over 4, you can't do anything with it. The 4 stays forever. So you keep that one. Next is 4 pi over 4. 4 pi over 4 reduces. 5 pi over 4 does not reduce. 6 pi over 4 reduces. 7 pi over 4 stays. And then what's 8 pi over 4? 2 pi. Okay, so that's a full circle. So again, look, you were going in order. 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8. Out of these, some of them, the 2 and the 4 will go away. 4 will become a 2. 4 will become a 1. 4 will become a 2. You want to throw those away. You only want to keep the ones where the 4 will stay forever. Yeah.
Is that any like a pi over 2?
Yeah, that isn't important right now. It's these. This is focus on these. Okay. Next, the pi over 3. Yeah.
You always start with the number in that exact.
Yes, yes.
The number being n is like it's the number times 2. So it's just like
Not every time.
okay,
Yes. Okay. Yeah.
like this.
Yes, the last one.
So the last one is
Mhm.
for
Right, but that one you don't write it. 7 pi over 4 is the one you write. Okay.
Do we need to write down the 1 pi over 4?
Yes. Okay, now let's see what the labels are for the pi over 3. Okay, so for the pi over 3, the pi over 3 is always the biggest increment from here. So pi over 3. Well, right now, let's just focus on these four and then we'll focus on putting them together. So this is pi over 3. Now, again, you're going to go 1, 2, 3, 4, 5. Okay, 1 pi over 3 is good. We can take that one. 2 pi over 3, that's also good because it doesn't go away. The 3 doesn't go away. 3 pi over 3, that's no good. 4 pi over 3 we can use. 5 pi over 3 we can use. What's 6 pi over 3? 2 pi, which you're done. Okay? Yes.
Why don't you put the 2 pi over 3 next to the pi? Why
Because the ones... So pi over 3 is this line. All the ones that are that distance away from the x-axis are pi over 3. So pi over 3, like they're all those. Okay?
You always skip the middle one?
Yes, it's always this one. Look,
So it's those huge
you know what? Why don't you guys wait until I finish teaching so it all comes together, okay? Because we're just doing little increments, okay? All right. Now, let's talk about quadrantal angles. A quadrantal angle is an angle where the terminal side lies on either the x-axis or the y-axis. So those are the corners. Okay, so this we know is pi. This we know is 0. Halfway we know is pi. Halfway in between 0 and pi is half a pi, pi over 2. So here, half a pi, 1 pi, 1 pi and a half. 1 and a half is the same as 3 over 2. So this is 3 pi over 2 and 2 pi. So do you see how these ones on the corner, they already have their angles? This is pi over 2, pi, 3 pi over 2, 2 pi. That's why the other ones can't be one of those, because those are different angles. Because we start with 0. When your angle is here, it's 0 degrees. You go up to pi, 3 pi over 2, 2 pi. Okay, now we're going to put this all together. Okay? On the next page, we're going to put this all together without looking back. All right? So let's go ahead and do this. Now, you should be able to locate angles on a circle. So again, we always start with the quadrantal, the ones on the corner. This is 0. Opposite to 0 is pi. How much is it at the top? Half a pi, which is pi over 2. This is 1.5 pi, but nobody writes 1.5. It's 3 pi over 2. And then finally, it's 2 pi. Now, you have 3 increments here. So now I'm going to start labeling them. This very first increment, okay, that corresponds to these. All right? Why does it correspond to these? Because all 4 of these are the same distance away from the x-axis. Do you see that? Same distance away from the x-axis. So those 4. Huh? Now, the smallest increment, right? This is the smallest increment. It's when you divide it into the 6. Remember, we divide into 3s, 4s, and 6s. When you take 1/6, that's the smallest amount of like chocolate you'll get. So this will be pi over 6. Now, all of those other ones that I've labeled are also going to be something pi over 6. So all of these are going to be something pi over 6. So now, let's see. We're going to do the coefficients, okay? 1 pi over 6. Then we're going to find the ones that doesn't cancel with the 6. Does 2 pi over 6 cancel?
Yes.
Does 3 pi over 6 cancel? 4? 5? 5 is the one I take. Next. Is 6 okay? 7? 8? 9? 10? 11? 11 works. Okay? So 11 pi over 6 is the last one. The one that doesn't reduce with the 6. Okay. The next one we're going to do is the pi over 3. Pi over 3 is the highest one. Okay? The uppermost one. So these 4 are the pi over 3s. These are the farthest from the x-axis. The farthest from the x-axis. You see that? Farthest from the x-axis. All right? So this gets the pi over 3. Okay, now look. 1 pi over 3. That works, right? 1 pi over 3 is, the first ones are always the 1. Next, 2 pi over 3. Does that work?
Yes.
Okay. How about 3 pi over 3? Does that work? 4 pi over 3?
Yeah.
5 pi over 3? 6 pi over 3? That's 2 pi. Okay? Now, the middle increment is what? Pi over what? 4. Pi over 4. So all of these are going to be the pi over 4s. Okay, first is 1 pi over 4. Now, does 2 work? 3? 3 works. 4? 5? 6? 7? Okay. And these are all of the angles. Now, you can't memorize these. It's too many to memorize. It's too many to memorize, and it's really silly and unnecessary to memorize because the minute you're rushed, the first thing you forget is the stuff you memorized. So in order to find 7 pi over 4, you just go, okay, 1 pi over 4, 2, 3 pi over 4, 4, 5, 6, 7. 7 pi over 4 right there. And you can keep going. 8 pi over, okay, 9 pi over 4. What's the next one that doesn't cancel? 10, 11, 12, 13, 14, 15, right? You can keep going forever and ever and ever, okay? All right.
So we have to remember like the 6, the 4.
Yes. The ones that you need to remember, absolutely. The ones that you need to remember are that the pi over 6 goes here. The pi over 6 goes here. The pi over 4 and the pi over 3. right? You have to remember that it's 6, 4, 3. And you have to know 1/6 is the smallest amount. A quarter is a little bit bigger. A third is the biggest one of them. Okay? So 6, 4, 3. They also go, in opposite order.
Always 6, 4, 3.
Always 6, 4, 3. There is no other number.
So it's always the same.
6, 4, 3, 2.
It's always the same. Like
It's always the same. It's always the same.
just need to like,
6,
not
4,
memorize it,
3.
know how it works.
Huh?
You need to memorize it, but just like know how it works.
Exactly. You just need to know how it works. It's the 6, 4, 3, and then all of these are the 6s. All of these are the 4s. All of these are the 3s. They're at corresponding locations. Yes.
In theory, for a quiz, would you give us a blank one?
No. No. No.
Oh, so we don't never. Okay. Let's just.
Oh, would I give you one to fill out?
Yeah.
No. But you have to draw them. Look, right here. You have to draw them. Okay. Okay, so let's draw these. Okay, so to draw them, so it says draw each angle and state the quadrant in which the terminal side lies. So here we go. So here's the x and y axis. Here we go. This is the initial side. You have to show me that. Now, this is a pi over 3. Okay, so here I have 1 pi over 3. What's the next one? How many pi over 3? What's the next one that doesn't cancel? 2. What's the next one that doesn't cancel? 4 pi over 3. What's the next one that doesn't cancel? 5 pi. Okay, so 5 pi over 3 is here, right? And then you have to do the loop that goes like that.
You wouldn't draw a circle?
Oh, and that's
You
where
don't
the
have to
3
draw a
is, because
circle.
pi over 3 is
Right,
there, and that's how you
right,
do it.
right. Okay, now, in what quadrant does this lie? So you know the quadrants are 1, 2, 3, 4. What quadrant does this lie in? Fourth quadrant. Okay? Okay. I'm going to go down instead of across. So let's do 7 pi over 6 first. I want to do the negatives later. So 7 pi over 6. Here we go. We start here. And then the pi over 6s, right? These are like, close to the x-axis. So 1 pi over 6. What's the next one? 5 pi over 6, right? There is a little bit like, you go through it in your mind. Okay, so that's not what I want. What's the next one? 7 pi over 6. So I'm over here. Don't forget to do that loop. What quadrant is this in? First, second, third, fourth? Third. Okay?
Is this going to be like on the quiz?
Yes. So you can also do
Will
like
you give
quadrant
us,
3.
what's it called?
A blank circle? No.
Like a
Yes.
Okay, so we don't have to draw it like this. Like we'll just have to write
Right.
arrow, like wherever it is. In the
Yeah. So I can show you the
really
practice
going down.
test. So I have the practice quiz up. I'm sorry, not up. So like I'll give you like these for example, okay?
Do we have to write it in Roman numerals, or can we just write it?
No, you don't have to write it in Roman numerals. Okay. So here we go. Okay, 4 pi over 3. Okay, so this is the initial side. Okay, so the first one is 1 pi over 3. What's the second quadrant? What's the third quadrant? 4 pi over 3, right here. Okay, so this is in quadrant 3. You can also write it like that. Okay? So we're building, right, little by little to like the big idea, which is in section 6. Okay, 11 pi over 6. So I start here. Okay, pi over 6. Is it close to the x-axis or far away? Close to the x-axis, because 1/6 is really like very little. So 1 pi over 6. What's the next one? 5. What's the next one? 7. The next one is 11. Now, so it goes like this. Had I given you, okay, so what quadrant is this in? 4. Had I given you 13 pi over 6, where would that be?
One above.
The one above, right? So look, this is 11 pi over 6, then it's 13 pi over 6.
So is that the
Right?
first
What would this
question?
one be?
15.
15 and 6 reduced by 3.
16.
17.
Then
17, then 19.
Then 21.
Mm-mm.
22.
Mm-mm. 23. Right? Six is tricky because it divides by 2 and by 3. Okay. But basically good. You guys get the idea. Good. I'm very happy. Yeah.
So for 7/6, where would the dot be? Because I don't understand like the closest.
The closest one. So like 7 pi over 6, it's like this one. Right? Here. This red one here. Okay. All right. So let's go here.
Oh, but it's the opposite.
Now we're going to do the negatives. We're going to go in the opposite direction. So here's my initial side. So now I'm going to go downward. 3 pi over 4. Remember the pi over 4s are halfway, right? So what would this first one be? Negative pi over 4. Okay? Here would be negative pi over 4. And then what would the next one be? 1 pi over 4. 3 pi over 4. So negative, okay, hang on. Negative 3 pi over 4 would be here. Okay? Do you see how we went in the, yeah.
You do it one more time. So then would that be the third one?
So, yes. So this is here, pi over 4. 1 pi over 4. Then 2 pi over 4 doesn't work. 3 pi over 4. So negative 3 pi over 4 is here, huh? Pi over 4 is in the middle. So this is, again, in quadrant 3. The quadrants don't change because it became negative. They're like standard, okay? It's like the room numbers don't change if you walk one way in the hallway or if you walk the other way, right? Like the room numbers stay, okay? All right, so negative pi over 4. So here we go, initial side. I'm going to go this way now. So what's that first one? Pi over 4. So that's the one, negative pi over 4. And it's in the fourth quadrant.
For this next one, isn't it just the one going straight?
Yeah. So take a look at this one. Now this is 3 pi over 2. Okay, that's a quadrantal angle. So look, this is half a pi, 1 pi, 1.5 pi this way. So it's literally on the axis. It doesn't. There is no, that's a quadrantal angle. It doesn't fall into a quadrant, so you just say none. Sorry, you don't say anything. Okay?
And so it's that's half pi, right?
Right.
And then the next one.
Is 1 pi, then it's 1.5 pi. Okay? Okay. Nothing. If it's on the x or the y-axis, these are called quadrantal angles. They don't fall in any quadrants. They're just on the border, so that's it. They're just quadrantal angles. Pi, yes. So now negative pi. Okay. So negative pi. So here's where we start. And I'm going to go in the negative direction. This way. Negative half a pi, full pi, right here. Okay, that's how it looks. Okay? And again, there is no quadrant here because this is a quadrantal angle. It doesn't fall inside any quadrant. Okay? Okay. Yeah.
Can you show me where negative pi over 6 is?
Negative pi over 6 is here.
Okay, so it stays.
Yeah, right. They all stay, right? It's just, yeah. Okay. For each angle below, find one positive and one negative angle that is coterminal. So this is review from before, right? But students usually, forget. So what we're going to do is for the positive one, we're going to add how much? 2 pi, right? If it's in radian, we got to be in radian. And you should, you can use your calculator for these, remember? So, no, don't change them to degrees. Leave them in radian. So here's how I do this. 2 pi over 3 plus 2 pi. Your answer is going to be, something in pi. But guess what else is going to be the same? The denominator here, the 3, is also going to be the same denominator as this. So I actually, when I set this up, I set it up with my template, and then I put it in my calculator like this. Let me do this, and then I'll take a question. So this is going to be 2 over 3 plus 2. That's 8 over 3, right? I already have my template here, 8 pi over 3. Do this because A, do not put pi into the calculator. It'll mess it up. All you're doing with the calculator is the fraction. And then B, put the template there so you don't forget about the pi. Let me do one more and I'll take your question. So for the negative one,
It's about the 2 pi.
okay, hang on. Minus 2 pi, right? So we're going to do, oh, again, this is going to be something, pi over 3. Okay, hang on. I just want to do this and then I'll answer all your questions. Okay, so this we're going to do 2 over 3 minus 2, and I get negative 4 over 3. So negative 4 pi over 3. So one of them is positive, one of them is negative. Now, I'm going to give you about 4 minutes to do B, C, and D here. Okay, on your mark, get set, go. Don't call out any answers, just write them down. Here we go. So for C, we subtract, we get a positive. We subtract again, we get a positive. So now I'm going to subtract again, and I'm going to get negative pi over 2. Okay, hang on. Now look, this is your negative one. This and this can be a positive one. But if initially you had done 11 pi over 2 plus 2 pi, and you got 15 pi over 2, that also works for your positive. There are an infinite number of answers for these, okay? All right, negative 13 pi over 18. What's the positive one? Is it? Yes, 23 pi over 18. What's a negative one? Right. Okay? All right, good. Okay, so let's see about homework.
Press start.